inequalities. And let's just review what inequality is real quick. If I said that 5 and 3, I don't want to say they're equal because they're not. But we want to say that one's bigger than the other. So how do I write? Yes. And so I can turn this around and I can do the 3 and the 5 and that it still opens towards the 5, right? Mm-hmm. Well, when we're doing inequalities with x, if I say that x is greater than 7, I could list all the numbers greater than 7, like 8 and 9 and 10.
That would take forever.
It would take forever because it keeps going on and on and on. But 8's not the only number. 7.1 is also bigger.
Oh,
okay?
my word.
And 7.01 is also bigger. And 7.0001 is also bigger. And there's no end to the number of zeros I could add to that, and it's with a 1 in there, and it's still bigger than 7. And so for us to do this more accurately, it would be better to actually use a graph. And so let's do that on the next page. So if we do x is greater than 7, and I have we're going to do this as an inequality on one of them, and it's very similar to when we graphed lines, just dots, with a little added extra. And so if I have 0 right here, and I go 1, 2, 3, 4, 5, 6, 7, okay, we don't put a dot, because that would indicate that it's exactly equal to 7, okay? We put an open circle, because it's not equal to 7, but that circle gives us an indication that that is kind of like a boundary of some sort. Your book is going to show you that you will say greater. All the numbers that are greater are going to go this direction. And it's going to show you that you can come over here and like color this in. When I was teaching this, sometimes it's difficult as a teacher to be able to see that they shaded in, because some people are really light shaders and some are like wild shaders, and so it gets really messy in here. Or they just draw exactly on that line, and you barely can see that they highlighted it and make it bigger. So I would like to suggest that you just come up and go like that, so it's extremely clear what you mean. Okay?
Okay.
Now we're going to do another graph. We're going to go x is greater than or equal to, we're going to say 5. Okay, this one is a little more straightforward because 5 can be stuck in there and it become true. And then I can list 6 and 7 and 8 and 9. But I can list all the decimals in between, so I couldn't just draw a line and put dots everywhere. I'd have to do this continuation thing, okay?
So would you circle 5 and then keep going up?
Yes. Well, we're going to circle 5.
Oh, and then you'd make 0. The lines go either... No.
1, 2, 3, 4, 5.
I'm trying to remember because I've done this before and I know that it's something. I just can't remember exactly which way.
We know we're going to go this way, right?
Right.
But how do I, as opposed to difference, I had to indicate that it was just not quite, it's not 7, but it's 7.1 or 7.01. But we can say that this is exactly 5. Exactly 5 works. So just like when we were graphing these on a number line earlier, we can put a solid dot to indicate that 5 is the beginning and everything else bigger. This one up here, this open circle indicates that 7's not the beginning, but it's really, really, really close to 7. That is. And so we have an open circle whenever my inequality has not the little equal sign in it. And I have that closed circle whenever it's equal to. Okay? That way it gives us very specific of what numbers are allowed to be in that inequality. Okay? And so that is the rest of your work. That's all.
Awesome.
Yeah, so if I have you numbers like x is less than -2, am I going to have an open or closed circle?
Open.
Okay. And you don't have to do this on graph paper. It's not required. I have them in here just for helpfulness. Because when I'm asking you to graph these, I need a 0 somewhere. And I need and I know that -2 is on this side. So I just need, and I don't even need you to make marks if you don't want to. I only need that you have a -2 over there.
And then I would just do like that and then...
Very good.
Like that?
Yes.
Okay.
Yes. And less. Now, we said that x is less than 2. Notice how I wrote these. I put my x on this side, and I put my x on this side. Be really cautious of what I'm going to tell you. It doesn't work. It only works if X is on the left. But I want you to notice that this looks almost like an arrow.
Oh, yeah.
And it looks like an arrow in the direction that I graphed it. And over here, looks like an arrow. And I went this direction in my graph, okay?
Oh.
That isn't, you can do that, but you're not really understanding why you're doing it. If you realize that X is less and you're pointing towards the less, that would be a better way of doing it. But after you do this enough times, and if X is on the left, then you can use the little arrow. It looks like a little arrow. I've had students ask me, is that just pointing towards the answer? I'm like, well, if it was it kind of is. But if I said that -5 is greater than X, then I can't do that.
Right.
So I have to come over here, and I have my 0, my -5. And if I read it this direction, and I say X is smaller than -5, or -5 is greater than X, which direction is my arrow going to go?
This way. I mean this way.
Yes, this way. And it's not used as an arrow now.
Yeah.
So be cautious to memorize. I don't like to memorize things that have exceptions. That's like memorizing English stuff. And the math stuff doesn't have these exceptions. It just works. And so if you remember things by that X is smaller, then you point towards the smaller side, then it's going to be always working. Okay?
Right.
All right. Questions?
Nope.
Okay.